Good day, everyone. Today, we'll be showing you a presentation on regression analysis, its results, discussions, conclusions, and recommendation from various researches, both published and unpublished. According to Wikipedia, linear regression is a model that estimates the relationship between a scalar response and one or more explanatory variables. A model with exactly one explanatory variable is a simple linear regression. A model with two or more explanatory variables is a multiple linear regression. This term is distinct from multivariate linear regression, which predicts multiple correlated dependent variables rather than a single dependent variable. We will going to tackle four main topics: results and discussion, conclusions, and recommendations. Without further ado, let's start with the presentation.
The first question that we need to answer is what are the statistic reports? To answer this question, let's divide it into three parts because in the statement of the problem for an regression analysis study, it has three different type of questioning, such as talking about the level, second, talking about the significance of the relationship between the IV and DV, and the third one is regression analysis on the influence between the IV and. Let's start with the first one, which is determining the level of each variable. When determining the level of each variable, researchers usually report descriptive statistics. Here are the statistics and tools commonly seen in the result. First, we have the mean or average. The purpose of this is to find the central tendency or the average response of the participant for each variable or indicator. Example, you have the mean score equal to 4.25. This indicate a very high interpretation. Second, standard deviation. The purpose of this is to measure how spread out or close the student responses are from the mean. A small SD means the responses are close to the mean. A large SD means they are more spread out. Third one is median. The median is the middle value when all the data are arranged in order, either from lowest to highest or highest to lowest. It tells you to the center of the data, especially when the data are skewed or the distribution are not equal. Second is determining the significance of the relationship between the IV and DV. If your data is ordinal or if the relationship is nonlinear but monotonic, it is much better if you will use Spearman correlation. But if your data is continuous, it is much better if you will use Pearson correlation. If you will use Spearman rank order correlation analysis, here are the statistics that are usually reported in the results. First, Spearman rho or the P or RS. This tells the strength and direction of the monotonic relationship between two ranked variables, the IV and DV. If you have positive rho, this means that as one variable increases, the other increases. If you have negative rho, this means that as one variable increases, the other decreases. Example, if your RS is equal to 0.725, this indicates a strong positive correlation. But if your RS is equal to negative 0.432, this indicates a moderate negative correlation. Second, p-value. This tells if the correlation is statistically significant. It has two rules. First, when p is lesser than 0.05, this means a significant correlation. But if the p is greater than 0.05, this means that it is not significant. And if you will use person-product moment correlation analysis, here are the statistics that are usually reported in the results. First, persons R, or the R value or correlation coefficient. These tell us the strength and direction of the linear relationship between two continuous variables, the IV and DV. For example, your R is equal to 0.68. This indicates a strong positive linear correlation. But if your R is equal to negative 0.35, this indicates a moderate negative linear correlation. Second, the R-square, or the coefficient of determination. This tells us how much of the variance in the dependent variable is explained by the independent variable. Third, p-value. This tells us whether the correlation is statistically significant. The same rule if you will use to Spearman rank order. The third is determining regression analysis on the influence between the IV and DV. For multiple regression analysis, here are the statistics reported in the result. First, for each independent variable, we have the unstandardized coefficient or B. This shows the actual change in the dependent variable for every 1 unit increase in the independent variable, keeping all other variables constant. The purpose of this is to know the real world or raw effect of each independent variable on the dependent variable. Second, the SE or standard error. This measures how much the unstandardized coefficient B would vary if the study was repeated many times. The purpose of this is to judge the precision or reliability of the B value. A smaller SE means the estimate is more reliable. Third, standardized coefficient or the beta, a version of the coefficient where variables are standardized, converted to have mean equal to 0 and standard deviation equal to 1, removing units. The purpose of this is to compare which independent variable has the strongest effect on the dependent variable, regardless of original units. The fourth is t-value, a test statistic used to determine if the B coefficient is significantly different from 0. The purpose of this is to help decide if the independent variable significantly predicts the dependent variable. Lastly, p-value for t-test. The probability that observed effect t-value happened by chance if there is actually no real effect. The purpose of this is to determine statistical significance of each independent variable, usually compared to 0.05. For overall regression model, we have the R or multiple correlation coefficient. This represents the strength of the overall relationship between all independent variables together in the dependent variable. The purpose of this is to measure how strongly the predictors together relate to the outcome. Second, the R squared, or coefficient of determination. The proportion percentage of the variance in the dependent variable that is explained by the independent variables. The purpose of this is to show how much of the variation in the dependent variable is accounted for by the predictors. Third is F ratio or ANOVA for regression, a test statistic that compares a model with no predictors to the model with predictors to see if the model is a good fit. The purpose of this is to test if the overall regression model significantly predicts the dependent variable. Lastly, p-value for f-test, the probability that the f ratio happened by chance if the model has no true effect. The purpose of this is to determine if the regression model as a whole is statistically significant. For regression or linear analysis, here are the statistics reported in the result. Estimate, standard error, t-value, and p-value. Since I already discussed what is standard error, t-value, and p-value, I will only discuss what is estimate. So estimate B or coefficient. The estimate represents the expected change in the dependent variable for every 1 unit increase in the independent variable, holding all other variables constant if multiple predictors. It tells you the size and direction of the effect of the independent variable. The purpose of this is to describe exactly how much and in what direction, positive or negative, the IV is influencing the DV. If the estimate is positive, it means that as the independent variable increases, the dependent variable also increases. If the estimate is negative, it means as the independent variable increases, the dependent variable decreases. And that is for the first question, what statistics are reported?
And now, let's proceed to how tables and figures are presented in the result and discussion. This part is very important because it helps readers clearly see the findings or results of the study. First, tables are numbered and titled. So each table has numbered like table 1 or table 2 and a clear title that tells what the table is about. For example, one table might be titled Level of Students' Mathematical Belief. So this title tells the readers what kinds of data is shown in the table. Numbering helps organize the information and it also makes it easier to refer to the table in the discussion. Second, tables are used to show data clearly. So, they are arranged in rows and columns showing values like the indicator, what is being measured, the mean, the average score, the standard deviation, how much the score differ from each other, and the descriptive levels such as very high, high, moderate, low, or very low. So next, after each table, the results are explained in words. So the writer includes a short paragraph to explain what the numbers in the table means. So this explanation helps readers understand the data more easily. So especially if they are not familiar with statistics. Next, table and figures support the text. This means that the data in the table are used to back up what the author is saying in the discussion. So if the author says that students are confident in learning mathematics, so the table should show high scores in confident. So the table and text work together to clearly present the findings.
How are results discussed in relation to research questions or hypotheses? The first one, we have results directly address whether each research question was answered or hypothesis supported or rejected. This means that the results section should clearly and directly answer the research questions or confirm or reject the hypothesis stated in the introduction. The results should be relevant and specific to each question or to the hypothesis. The second one, we have statistical evidence is presented that specifically relates to each research question or hypothesis. At this point, it emphasizes the importance of using statistical analysis to support the findings. The statistical evidence should be directly related to each research question or hypothesis, providing quantitative support for the conclusions drawn. The third one, the meaning and significance of findings are interpreted relative to what was originally asked. In here, the focus is on interpreting the results in the context of the original research questions or to the hypothesis. The discussion should explain what the findings mean, why they're significant, and how they contribute to the broader understanding of the topic. The fourth one, results are organized in the same sequential order as the research questions or hypotheses were presented. At this point, it highlights the importance of consistency and clarity in presenting the results. By following the same order as the research question or hypothesis, the discussion remains organized and easy to follow, allowing readers to see how each question or hypothesis is addressed.
In this part, we are going to tackle conclusions drawn from the findings. Or, in simple terms, conclusions are just a summarized version of the results and discussions without technicalities. First, it examines the significance of predictor variables, the strength of relationships, the amount of variance. Second, the conclusion directly addressed the initial research questions or objectives. Compare the findings to previous research, noting whether the results support, contradict, or extend prior studies. 4. It identifies key predictors and influential factors, most important variables that influences the outcome of interest. Some documents acknowledge the limitations of the study, such as sample size, specific methodologies, or potential confounding factors.
Now let's move on to the next discussion about what types of recommendations are provided in the regression analysis. So based on our observation from the published research, these are the types of recommendations provided in the regression analysis. First, policy or practice recommendations. If the research examines trends in education, business, or social sciences, the findings can suggest practical changes. For example, if regression analysis shows that student engagement significantly impacts math performance, a recommendation could be to adopt interactive teaching methods. Second, improving model accuracy. If limitations were found in the regression model, like multicollinearity or a low R-squared value, recommendations may suggest refining variables, increasing sample size, or exploring alternative statistical methods. Third, future research directions. Often, research regression analysis highlights areas that need further investigation. Researchers might recommend testing different predictor variables or using more advanced models for deeper insights. And for the fourth one, strategic decision making. In business or economics research, regression analysis can guide financial decisions, marketing strategies, or operational changes. If price increases lead to reduced demand in study, a company may be advised to reconsider pricing strategies. And lastly, tailoring interventions. In educational or healthcare research, regression analysis might reveal which demographic groups benefit most from specific interventions. Recommendations could include personalized programs for struggling students based on predictors identified in the study. And that are the types of recommendations provided in the regression analysis based on our observation from the published researches.
The types of recommendations from different studies that are provided earlier are thoughtfully directed to specific groups who have the capacity to act on them and has the opportunity to implement those suggestions to drive better outcomes. Recommendations are calls to action, inspiring